Kusto Query Language KQL is a powerful tool used to interrogate logs and telemetry data in Azure. It is designed to be easy to read and write, making it accessible for both beginners and experienced users. KQL is primarily used within Azure Monitor, Application Insights, and Log Analytics to analyze large volumes of data quickly and efficiently. Understanding KQL is essential for implementing an effective instrumentation strategy in DevOps, as it allows teams to gain insights into system performance, detect anomalies, and troubleshoot issues. Log interrogation is a critical aspect of maintaining and optimizing any application or system. By analyzing logs, teams can identify patterns, detect errors, and understand user behavior. This process helps in proactive monitoring, ensuring that potential issues are addressed before they escalate. In the context of DevOps, effective log interrogation supports continuous integration and continuous deployment (CI/CD) pipelines by providing real-time feedback on system health and performance. KQL plays a pivotal role in this process by offering a robust querying mechanism to sift through vast amounts of log data. KQL queries are composed of a sequence of statements, each performing a specific operation on the data. The basic structure includes a source data reference, followed by a series of operators that filter, project, and aggregate the data. For example, a simple KQL query might start with a table name, followed by a filter condition to narrow down the results. Understanding this structure is fundamental to writing effective KQL queries. The syntax is intuitive, resembling SQL, which makes it easier for those familiar with database querying languages to get started. Filtering is one of the most common operations in KQL. It allows you to narrow down the data to only the relevant records. The where operator is used to apply filters based on specific conditions. For instance, you might filter logs to show only errors or events that occurred within a certain time frame. This capability is crucial for pinpointing issues and understanding specific scenarios within your logs. By mastering filtering, you can quickly isolate the data that matters most, making your log interrogation process more efficient. Projection in KQL is used to select specific columns from the dataset. The project operator allows you to specify which fields you want to include in the output. This is particularly useful when you are only interested in certain aspects of the data, such as timestamps, error messages, or user IDs. By projecting only the necessary columns, you can reduce the amount of data you need to process and focus on the most relevant information. This step is essential for creating concise and meaningful reports from your log data. Aggregation is a powerful feature in KQL that allows you to summarize data. The summarize operator is used to perform calculations such as count, average, min, and max on your data. This is particularly useful for generating metrics and KPIs from your logs. For example, you might use aggregation to calculate the average response time of your application or the total number of errors over a specific period. Aggregating data helps in identifying trends and patterns, providing valuable insights into the overall performance and health of your system. Joining datasets is a common requirement when working with logs from multiple sources. KQL provides several operators for joining data, such as join and union. These operators allow you to combine data from different tables based on common fields. For instance, you might join application logs with user activity logs to get a comprehensive view of user interactions and system responses. Understanding how to effectively join datasets in KQL is crucial for creating holistic views of your system's performance and behavior. Time series analysis is a key aspect of log interrogation, especially for monitoring and troubleshooting purposes. KQL provides robust support for time series analysis through operators like makeSeries and extend. These operators allow you to create time-based visualizations and detect trends over time. For example, you can use time series analysis to monitor the number of requests per minute or the error rate over the past week. This capability is essential for identifying performance bottlenecks and understanding the temporal aspects of your system's behavior. KQL offers a wide range of advanced functions that can enhance your log interrogation capabilities. Functions like parse, extract, and mvexpand allow you to manipulate and transform data in sophisticated ways. For instance, you can use parse to extract structured information from unstructured log messages, or mvexpand to handle multi-value fields. These advanced functions enable you to perform complex data transformations and gain deeper insights from your logs. Mastering these functions can significantly improve your ability to analyze and interpret log data. Visualization is a powerful way to interpret and communicate log data. KQL integrates seamlessly with Azure Monitor and other Azure services to create rich visualizations. You can use the render operator to generate charts, graphs, and other visual representations of your data. Visualizations help in quickly identifying patterns, trends, and anomalies that might not be obvious from raw data alone. By leveraging KQL's visualization capabilities, you can create intuitive dashboards that provide real-time insights into your system's performance and health. Understanding real-world use cases can help you appreciate the practical applications of KQL. For example, a DevOps team might use KQL to monitor application performance, track deployment success rates, and detect security incidents. Another use case could involve analyzing user behavior to improve the user experience. By exploring these scenarios, you can see how KQL can be applied to solve real business problems and enhance your DevOps practices. These examples demonstrate the versatility and power of KQL in various contexts. To get the most out of KQL, it's important to follow best practices. This includes writing efficient queries, using appropriate operators, and optimizing performance. For instance, always start with the most restrictive filters to reduce the amount of data processed. Use project to limit the columns returned, and summarize to aggregate data effectively. Additionally, take advantage of KQL's built-in functions to simplify complex queries. By adhering to these best practices, you can ensure that your KQL queries are both efficient and effective, providing valuable insights with minimal overhead. While KQL is a powerful tool, it's not without its challenges. Common pitfalls include writing inefficient queries, overlooking important data, and misinterpreting results. To avoid these issues, it's crucial to thoroughly test your queries and validate the results. Use the limit operator to test queries on smaller data sets before running them on large volumes of data. Additionally, take advantage of Azure's diagnostic tools to troubleshoot and optimize your queries. By being aware of these common pitfalls and knowing how to address them, you can make the most of KQL for log interrogation. Mastering KQL is a valuable skill for any DevOps professional. It empowers you to interrogate logs effectively, gain deep insights into system performance, and make data-driven decisions. As you continue to develop your KQL skills, consider exploring more advanced topics and integrating KQL with other Azure services. Practice writing and optimizing queries regularly to build your proficiency. By doing so, you'll be well equipped to implement a robust instrumentation strategy and drive continuous improvement in your DevOps processes.